Okay, so real quick, just a little terminology, kind of getting this very basic review. What's an equation? Well, an equation, real simple. Equation is anything that has an equal sign in it, right? So it's two expressions are linked by an equal sign. So obviously, I won't even insult you by asking you which of those are equations. Obviously, those are equations. What would we call these other guys? What do we call that? Expressions, yeah. Expressions are simply algebraic things that are built from numbers and variables. That's it. Anything that's built from numbers and variables is an expression. If I include an equal sign in there, it becomes an equation. So this is also an expression. Can anybody see another expression up there somewhere?
3x minus 7.
Yeah, 3x minus 7 would be an example, or even 12. 12 is a number. That's an expression. Okay? All right, so a little terminology. Oops. There we go. Okay, properties of equality. Very, very simple. This is stuff you already know. The addition property of equality and the subtraction property of equality just say that you can add or subtract the same term from both sides of an equation, or to both sides of an equation. Okay? A term, that's an important word in math. A term simply means anything that you are adding or subtracting is a term. If you want to add it or subtract it, you call it a term. Now, if you want to multiply it or divide it, and these similar properties just say we can multiply or divide both sides of an equation by the same, oh, that's wrong. I'm supposed to say factor. Darn it, I thought I fixed that. So instead of saying term there, that's actually supposed to say factor. Because things that we say, I'm going to point at you, I'm going to multiply or divide you, that means that's a factor that I'm pointing at. Things that are multiplied or divided are called factors. But all these fancy formulas really just boil down to what you already know, and that is, with an equation, you just have to treat both sides equally. What you do to one side, you have to do to the other side, right? And we already know that about equations. All right, so to solve an equation for a variable. Now, we very, very briefly, I wouldn't even really hardly talk about it, but when you do order of operations stuff, we might have spent a couple minutes one day on it. When we want to simplify something, we follow normal order of operations, right? And you guys did an assignment about that, where I gave you a bunch of stuff, a bunch of numbers jumbled together, and you had to simplify it down to a single number. How did you know what to do? Well, you follow order of operations, right? PEMDAS. Now, notice that the M and the D are included together, right? Because the multiplication and division are equal, right? M does not come before D. And the A and the S are together because addition and subtraction go together, right? But this is the order in which we simplify stuff. We have parentheses or grouping symbols first, you might remember. Then exponents, then we multiply and divide, and finally we add or subtract to turn stuff into a single number. And a quick example would be if I had something like, say I had 2 squared plus 5 over 3. Well, how do I do that? What do I do first? I got to work on the top of the fraction separate from the bottom, right? Because the top is grouped into one thing and the bottom is grouped into one thing, right?
Hey, apologize for interruption.
That's right.
Is Gabe here? Gabe? Can I borrow for just?
Yeah, you bet. Yeah. Okay, so I would work on the top first, and I would do exponents first, so that 2 squared would become a 4, right? And then I would add on the top and get a 9, and then on the bottom I got a 3. And then finally, after I've done all the stuff in the top and all the stuff in the bottom, I can figure out what that fraction simplifies to, right? And you guys were fine on that. That assignment went really well, not a problem. What I mostly want to get at here is the next step, which is not simplifying, it's solving. And this is really important. If you can get this, this is the link to everything we do, practically everything we do in Algebra 2. This means simplifying, but this is the direction we go if we want to solve for x, or any other variable for that matter, or isolate x. We go bottom to top, and reverse the order of operations. First, we're going to add or subtract things to both sides, then multiply and divide, then we undo exponents, then we undo parentheses. And if you can get that stuff down, that works all the way through Algebra 2 and beyond, and it makes algebra much, much easier, that very simple concept. Okay, so let's take a look at this. So if we're going to do order of operations backwards, now we're going to keep going, just keep working our way up that list until we isolate the variable. Now sometimes we're going to want to go ahead and simplify stuff first before we start to isolate. Okay, and we'll see some examples of that. Okay, let's look at this guy. Now here's a simple rule. If you remember this, it's helpful. If I can point to a single variable, then I can isolate it by reversing order of operations. Can I point to a single variable here?
Yeah.
X, yeah, there it is, right there, sure. There's the one X that I can point to, and therefore I can isolate it by reversing order of operations and starting at the bottom. So what's the first thing we would do then? I'm going to try to add or subtract. I'm going to see if I need to add or subtract to get that X by itself. And literally think of it as movement across the equation. Here I've got this equal sign in the middle. The X is on the left. My goal is to get that X all by itself on the left side of that equation. So I've got to go through the steps to move everything else away from it to the right. That make sense?
Yeah.
So the first thing is, we're just going to subtract 8. No big deal. Right, now what? Okay, I'm going to, you can say I divide by 2/9, but we don't like to divide by 2/9. Instead, we'll multiply by the reciprocal. We don't divide by fractions. It's easier to multiply by the reciprocals. So if I multiply both sides by 9/2, 8 times 9/2, that's really just 8/1, isn't it? Right? So I get 72/2 or 36, right? How would I know if I'm right? Plug it back in and check. Okay. Now what about this one? This one is a little trickier. Can I point to a single value of X there? Well, I can point to one of them, but there are 2 others, right? So because there were 3 of them there, I can't isolate X. I have to be able to point to only one X in the whole thing, and I can't do that yet. So that means I've got to simplify first, exactly. So I'm going to start off by working down the order of operations tree. As soon as I can isolate, I can turn that thing around and go back the other way. But I'm not there yet. So inside parentheses, let's work our way down. Inside parentheses, can I do anything? No, I can't, right? Inside the parentheses, X minus 2, they don't combine. 2X plus 7, they don't combine. There are no exponents to worry about, so we're on to multiplication and division. Now, I heard people say distribute. Where does distribute fit in this order of operations tree? Is that multiplying, dividing, adding, or subtracting? It's multiplying, isn't it? Right? Because when I distribute a 5, all I'm doing, and you really need to think about it this way, when you're distributing the 5, all you're doing is multiplying the 5 by that whole thing. But when you multiply 5 by a quantity in here, you have to distribute it to both parts. You have to multiply it separately by each part of that quantity, right? So I end up with, what, 5x minus 10 equals negative 8x minus 28 plus x, right? So we're multiplying there. That's good. Oh, what's this doing? There we go. No. There we go. Okay, so we multiplied. Now what's left? I still don't have a single x. So what do I'm just trying to simplify. So now what do I do? Okay, I'm gonna, well, excuse me. I'm going to add up like terms, aren't I? Right? Add and subtract. So over here, it looks like on the left side, I'm all done. Everything looks good. On the right side, I can combine those 2 x's. Good? Okay? So both sides are simplified, but I've still got 2 x's there. I've got to combine like terms. Now, there's one more small issue I want to deal with here. Excuse me. That's kind of important. Which direction do I want to push those x's in this case? They'll both work either way, but there's one small preference for one side, left or right. We want to go left. How come? Because I'll get a positive number of it, right? So I want to push the x's this direction, right? I'm going to add 7x to both sides, and I'll get 12x over here, right? That's good. Then I'll be dividing by positive numbers instead of negative numbers, right? So as a rule, We always collect the variables on the side where we have the most of them, okay? It'll work the other way, of course, but we want to make things easy. And then what about the, okay, now look where we are. Now, finally, we've got a single x that we can point to, right? And so we're going to shift gears. Now, instead of making this thing simpler, we're going to go into isolation mode. We're going to isolate that x, which means that we're going to start at the bottom and work our way up. So what's the first step we're going to try to do? Yeah, we're going to add and subtract stuff, right? This is the easiest stuff first. We want to push everything away from the x first by adding or subtracting. But what does that involve? Add 10, right? Add 10 to both sides. Okay? And then we move up to the next step, dividing. Divide both sides by 12, and I get negative 18/12, which simplifies to negative 3/2. Okay? Okay, one more example here that's kind of important I want to look at. This is a big, great trick. This guy. Okay. Now in math, you can beat your head against the wall here with this thing. If you're battling fractions the whole time, which is hard to do. I mean, it's not hard for you guys, but it's cumbersome and it's tedious. You're constantly having to add, subtract, and multiply and divide all these fractions. Right? Wouldn't it be nice instead if we could make a sort of a preemptive step here, do a first step to clean this thing up and turn it into a problem with no fractions? Wouldn't that be great if that were possible? Well, it is. How do we do it? Anybody know? Ah, okay, good. We're going to clear the fractions. That's what we call this trick, for lack of a better word. Okay, we're going to clear the fractions, and the way we do that is we take all the denominators on both sides of the equation. So what are the denominators? 3, 5, and 10, and we want to find the least common multiple of all those numbers, meaning the smallest number they all divide into equally. 30, right? 30 would be that number, the smallest number they all divide into evenly. Now, I'm going through this slowly here, and you might be thinking, I got it. But this is really important. If you get this trick, it'll save you a lot of time. So I'm going to multiply 30 through by both sides. And I want you to watch what happens with this when I do that, when I distribute the 30. And I'm going to give you a shortcut for doing this that you're really going to like. Okay, if I distribute the 30 to the 2/3, that's just multiplying 30 over 1 times 2 over 3, x, right? Distribute it to the 1/5. I got 30 over 1 times 1/5. On the other side, 30 times 2x. Well, that's easy. That's no fraction, right? That's just 60x. Minus 30 over 1 times 3/10. Now, when I'm multiplying fractions, how do we multiply fractions? Straight across, right? Unless we can reduce. It's always better to cross-reduce if we can. And an example of that is, well, there's no real hard ones on here, but if I multiply straight across, I'm going to get 60 over 3. That's a pretty big division problem, right? I mean, it could be a lot worse. So instead, if we can cross-reduce, we always do. What can I reduce up here?
30 and 3.
30 and 3. Cross-reduce. What do those reduce to? 10 over 1. 30 over 5. 6 over 1. And 30 over 10. 3 over 1. Now, I want you to notice something here. That worked out great. Did we luck out?
No.
Or was that always going to happen? How come, notice that when we cross-reduced, I got nothing but 1s on the bottom of my fractions, which means I don't even need the fractions, right? So what this really ends up being is 10 times 2 is 20x plus 6 times 1 is 6, 1's on the bottom, equals 60x minus 3 times 3 is 9 over 1. How about that? And now it's an easy problem to deal with, right? Shouldn't we have expected that, though? Didn't we know that this was going to happen because we purposely chose the number 30 from the denominators because the denominators all divided into it, right? And so we know right away if the denominators divide into 30 that they're all going to reduce like that, okay? So instead of going through this tedious process, I'll show you a little trick. Just do this when you're showing your work, which I'm going to have you do. I'm going to talk about that in a second. When I distribute this 30, and I distribute the 30 through to both terms, always, instead of just multiplying, and you can do it this way, but save yourself some hassle. Instead of just multiplying straight across 30 over 1, reduce first and multiply whatever you get from when you reduce by the numerator. So 30 over 3 is 10 times 2. What's 10 times 2? 20. No big deal, right? 20 over x. If I go to the next term, 30 over 5 is 6 times 1 is 6, right? Over here, 30 times 2x is 60x. Now, what about this guy? 30 over 10 is 3 times 3. So I get minus. See how I did that? That's the slick way to do it. Then you don't have to, I mean, that's really, it's always going to work. Whenever you're doing a fraction, it's always going to work that way. Okay? And then from here on out, it's easy. What are the steps I'd go through to solve for x here? We can skip these.
20x.
Subtract 20x to push the x's over here, then what?
Plus 9.
Add 9, and then
Becomes 8 over 3.
divide by 60, right? Okay. Okay. I think we're set. Oh, okay, one last thing before we go down there. What time is it, by the way?
It's 11:20.
11:20. So how much time do we have left?
Wait,
15 more minutes. Okay, well, maybe it's worth getting down. Okay, couple things, real quick. I want everybody to have notebooks in here. Did I tell you that yesterday in class? Okay, you gotta have math notebooks, not for notes, but I want you to write down your work on the Moodle problem. So if I ask you, I want to see your work on a Moodle problem, I want you to be able to turn to that. I'll say more about it later. I want to get you going. Use Firefox, even though I said not to yesterday. That's the culprit. Firefox works great. There were a couple problems that were messed up. One of them had a number to the 0 on the bottom. The other one was the perimeter of a square. Turn in the right answers, and I'll fix them when the assignment's due. Okay?
Are there any new assignments up?
Yes, 1.3 is up. Yeah, it's up. Okay, 205.